So in this video, we're going to talk about applying context window optimization techniques. And it sounds, again, more complicated than it is. This is my series on the Claude Certified Architect Foundations exam. I'm covering the 7 topics that I didn't do well on when I took the exam last. And this is the 6th of 7 topics. So the exact subdomain reads, apply context window optimization techniques, summarization, sliding windows, structured state objects, and selective retention to maintain response quality as conversations exceed practical token limits. So what are we talking about here? Well, it's, again, easier than it sounds. For whatever reason, that Claude exam makes everything sound very complicated, but at the end of the day, here's what we got. We know that when we chat with an AI agent, we have a limited set of memory that we could use for that, and that is known as the context. Now, depending on that context size, Claude will automatically implement truncation or blind compaction in order to deal with the fact that it's running out of room to remember things. We also know that somewhere between 75 and 85% of that context memory, when it's full, we're starting to degrade the quality of the answers that are produced because it's starting to hallucinate more. It can't quite make sense of the facts that it knows. And so we really need to streamline and control how much data we have in the context. Now, if we just let it randomly take care of itself, that might be fine, but in most cases, it's not exactly what we want to do because there might be some facts that we want it to remember, whereas other things we don't necessarily want it to remember. And if we just let it randomly truncate or remove stuff out of the context, we might be missing some of those important elements that we want to keep. So essentially, there are 4 techniques that allow us to deliberately choose what Claude remembers and what it can forget and how it does that. And so the 4 techniques are, the first one is, of course, summarization. And summarization essentially is that we're going to look at the entire chat history. We're going to summarize all of it and remove all of the fluff and filler, leaving what they call just the gist. So this is useful when having a summary of everything is okay. In other words, we don't have any specific numbers that we need to remember or have very, very detailed instructions or information that we previously provided to Claude be available as part of the chat. So the next one is the sliding window. And here we're basically saying that we don't care about most of the older history. So this works best when none of the questions or none of the turns, and a turn in this case is us typing to Claude and Claude returning an answer of some sorts. And that is one turn. So we don't necessarily care about the previous turn because it has nothing to do with the one that we're currently on. So in this particular case, we can truncate everything up to maybe the last 2 or 3 turns, just so we have something to refer back to. But everything older than that can be removed because it has no bearing on what we're currently doing with Claude. Next one on the list is structured state objects. And this one is basically JSON data for facts. So imagine that we're collecting order IDs, invoice numbers, dollar amounts. We promised a customer a specific refund amount, different things that we want to keep track of that are very specific facts. We can store them in this JSON object, which here is called a structured state object. And we can carry that object forward throughout the entire chat history. So it's definitely smaller than keeping track of all of the different iterations and the pros comments that Claude puts out, as well as the information that we feed it. So this is just, I'm holding on to these facts and I'm going to carry them over throughout the entire conversation. And last but not least, we have a selective retention. And this is useful when we want to preserve certain things within our chat history, but not everything. So think of this one as a filter. So we may go back to Claude and we'll say /compact, and then we'll say preserve information around this error and what we did to fix it, and maybe find this other paragraph or chat that we had during this session and preserve those, drop everything else. And so the selective retention works because it preserves the critical things that we want to save as part of the chat. Everything else can come out. And so here are the scenarios that we can use to work through some of what we just talked about. So first and foremost, we have this one, which is we have a customer support agent that handles long sessions, and we're collecting facts as we go along. So at some point, the conversation grows too long, but we're now, starting to misquote things. And that's because that random truncation or cleanup has happened and we lost some of this information. So the way we bypass that problem is with that structured output, the structured facts. So we're going to put it in JSON, and we're going to maintain the must remember data in that JSON and carry it forward throughout the entire conversation. Number two is we have really a Q&A type of chat going on, and none of the questions are dependent on one another. So it doesn't matter that 7 questions ago I asked something specific. The current question that I'm on has nothing to do with that, and so therefore, why are we keeping all of that in memory? We can then use that sliding window to keep maybe the last 2 or 3 turns and lose the rest. And so this always keeps our memory free, and we can continue that chat for a very long time without ever filling the context or burning more tokens than we need to. Next up is the brainstorming session. And this one is, as brainstorming sessions go, contains a lot of information throughout the day. So we don't necessarily want to keep track of all of what was said. Like there's stuff that clearly went into wrong directions. We backed out of it, and we have all this content that we really don't need. But we want to identify the general direction and some of the best points of the conversation. And so in this case, we want to summarize it. And summarizing it preserves that direction, the highlights of what we did, but gets rid of all of the finer detail. And last but not least, we have a long coding session that produces 3 specific features, but the rest is, back and forth chatter and maybe non-working things that we had to do. So we need to protect the working features of this particular chat. And this is where we would use the selective filter. This is the selective retention feature, and it allows us to say, well, preserve these 3 things, drop everything else. Now it gets even more interesting because sometimes we may want to combine these techniques together in order to really get the best of sort of all of these worlds. And you could do that. Here's the scenario that talks about that in particular. Basically, we're saying that we have a very long chat going on and certain tasks must be recalled exactly. We may need certain information like identifiers for different records or queries or things like that exactly as we entered them. And then we want to basically gauge a sense of the whole progress of our chat. So here we're going to use the structured state for task facts. We're going to use the sliding window for those recent turns so we can control that. And we're going to use summarization for the less important stuff. And so that combines multiple techniques together. So I will say that my last video on this was around context fork. And context fork is a preventative technique. It basically prevents you from filling up the context window that you have because you're going to break things out into subagents to do the work. In this particular case, we're talking about a remediation technique. In other words, this is something that is already happening in our existing context window, and we need to be able to deal with it. Like, we can't stop it, so we have to be able to deal with it. And these are the 4 techniques that we can use for that purpose.